lot of this you might have seen already before, and I know the physics students, you would have seen some of this already in physics with the sine, cos and tan. So not an awful lot to do. The first thing we need to do is just talk a little bit about different ways to measure angles. So the first way, which is most familiar, is we can measure angles using degrees. So in one full circle we have 360 degrees. Can we see okay? Yeah. Trigonometry. But that's just one way to measure angles. We actually have another way to measure it. I know the physics students know this one as well. Physics students, what's the other unit for measuring angles? Yeah, you're making the physics students look bad. Radians. How many radians in one full circle? 2 pi, very good, okay. So that's about 6.283 radians in a circle. But there's actually another way to measure an angle. Your calculator actually has 3 modes for measuring angles. There's actually 3 ways. I wonder if anybody knows the third way we can measure an angle. Yeah, actually you could look at the calculator for a hint perhaps. You've got 3 different modes. Degrees, radians, and what's the last one? Yeah, which? Gradians, yeah. Does anybody know how many? There's 400 gradients in a circle. The reason 400 is used is because it makes each quarter 100 then. Is the reason why. But we don't use this one, so you don't have to worry about that. And it's a little bit confusing. Does anybody speak Spanish? No Spanish? Yeah, good. In Spanish it's a bit confusing because the Spanish for the word degree is gradient, which makes it confusing because sometimes the students mix up the 2 modes on the calculator. But we don't have to worry about that because we don't use gradient. We just use degrees and radians. This one everybody knows, but we need to talk a little bit about this one now. Okay, can I scroll down? Sure. Yep. So how do we define a radiant? So 1 radiant is when we have enough of an angle so that this part of the circle, its length is also r. This is what makes 1 radiant. When this is r, this is r, and this is r. We need a little bit of vocabulary now actually. What's the name of this part? Well, let's start with something easy. What's the name of this part? The or. What's that called? The radius. And this part here to here? The arc, yep. And what about the whole thing? Yeah, that's it. The whole thing is called the circumference. So let's work out how much we have in radians in one full circle. Okay, let's see. If I just draw this again. The advantage of using the radian is that this distance here will always be equal to the radius multiplied by the angle. So for example, if you had 1 radian, then that means the arc will be 1 or long. If you had 2 radians, then that means the arc will be 2 or. Yeah. So this formula here, arc equals angle multiplied by radius, that's our first formula. And this only works if we're using radians.
What is the L?
The L is, sorry, this is the L here. It's the length from here to here, yeah. Okay, so if we have one full circle, what does the L equal in a full circle? Yeah? 360 degrees. And for the length, how long is the outside of a full circle? The circumference, how big is that? Yeah, in terms of the radius. 2 pi r, yeah. It's equal to 2 pi r. But we also know this is equal to theta r. So by looking at these two, we can get theta is 2 pi. And this is for a full circle. Which is what I said earlier, that for a full circle we have roughly 6.28 radians in a full circle. Okay, can I scroll down?
Sure.
Not yet? I heard a no. Okay. Now? Yeah? Okay. So how do we change from degrees to radians? Well, if we remember that 360 degrees equals 2 pi radians, we can get this kind of straightforward result. If you want to go from degrees to radians, the way you do that is you multiply by pi over 180 degrees. And if you want to go from radians to degrees, you multiply by 180 over pi. Okay, you got that? Okay, let's have a look. Before we do anything else, let's just look at a couple of examples here. So let's say I want to convert 293 degrees into radians. Well, that will equal 293 times pi over 180, which will equal 293 times pi over 180. Let's get that as a decimal. 5.11 radians. Okay, and let's try this example now. 2.7576 radians. Let's change that into degrees. Okay, so I'll let you do this one now. It should only take you a moment on the calculator. Yeah. It's usually at the bottom. On my calculator, it's here.
Yeah.
Yeah.
Thank you.
Did you get an answer here? Sorry, you get an answer here? 2.7576 times 180 over pi, what do we get? 2.7576 times 180 divided by pi, 158 degrees. Yeah. Okay. Continue. Yeah. Okay. Next. Did you need to write that down?
Right.
Yeah, go ahead. Next, we're going to have a look at Pythagoras. Physics students, you know him. Yeah, where is Sean actually? I know I'm missing Sean, KJ. Is he? Is he asleep? And Sean? Sean's asleep also? Okay. Next. The Pythagorean theorem, or Pythagoras' theorem. Everybody knows this, just maybe you don't know the name. So this works when we have a triangle here. And this triangle, do we know the name of this type of triangle? Right angle, yeah. A right angle triangle. And if this is A, this is B, and this is C, we have this. Everybody, I think, remembers this from middle school.
Yeah.
So what we're going to have a look at now is just, right, we'll just do the proof of this since it's quite short. It's actually, I think the last time I checked, I'll have to check for you, but there might be something, well, I'll tell you how many ways there are to prove it, but it's quite a large number.
Do we have proof that
in semester 2, there's some trigonometry proofs. Proven trigonometry results. Let's see. Okay, so I have at least 54 different ways to prove this. One is enough. I'll pick the easiest way. But there's actually 54 different ways to prove this, at least 54. Okay, so what we'll do first, we'll just draw a square. And we'll call this side here, this is A, and this length is B. And this is A, and this length is B. And this is A, and this length is B. And this is A, and this length is B. And we'll draw here A to A. Now, it's not a great picture, but that's also a square. Like that. Okay, let's have a look at the area here. Okay, can I scroll down a little bit? Yeah. Right, and we'll call this side here C. Okay, so if you look at this, the area of the 4 triangles, that would be 4 times a half B times A. Yeah, a half A times B. Plus the area of the square, that should equal the area of the whole thing. A plus B, yeah, squared. Let's see what we get. So we get 2AB plus C squared equals A squared plus 2AB plus B squared. Cancel, cancel, and you're left with C squared equals A squared plus B squared. So, like I said, it's a short proof, and this is the proof of it. Okay, can I scroll down? No. Not yet? Okay. It's a square.
Is there a name for that priority?
Let's see. I don't think so.
Some name who made that?
This is proof number 4, if you want a name. Of the 54 proofs I have on this page, it's the shortest proof. There are some amazing difficult proofs on this page. If you're interested, you can Google tonight. Let's see what page this is. Yeah, if you just Google proofs of Pythagoras theorem, you'll get hundreds of them. Okay, do we have this? Right, so let's have a look at just using this as an example. Okay. I will do an easy one. This is 5, this is 12, this is x. We want to find the x. Okay, so easy example to start with. So we have x squared equals 5 squared plus 12 squared. X squared equals 25 plus 144. X squared equals 169. So x is 15 then. So, like I said, an easy one to start. Okay, can I scroll down? No? Okay. Yeah? Okay. Right, next thing to look at. If we call this angle theta, these sides actually have names. This side here, because it's opposite of the theta, we call it the opposite. This side here, you might know the name, physics students? Yeah. Adjacent. And this side here, the longest side, is called hypotenuse. Now, I know some people, these are new words, so I want everybody to write these words down for sure. Yeah. Okay. If you have 3 sides, there's actually 9 different ways to compare 2 of the sides. So if you want to compare 2 of the sides, you can do this in 9 different ways. So for example, you could compare the opposite with the adjacent, compare the opposite with the hypotenuse, and you could compare the opposite with the opposite. But of course that one is not really useful because this will always be 1, so we don't really care about that one. You can also compare the adjacent with the opposite, the adjacent with the hypotenuse, and the adjacent with the adjacent, but again we don't care about this one because this one is always the same. And lastly, we can compare the hypotenuse with the opposite, the hypotenuse with the adjacent, and the hypotenuse with the hypotenuse. Again, we don't care about this. These 6 fractions have names. In semester 1, we'll look at this one, and this one. This is in semester 1. And then in semester 2, we'll look at this one, and this one. So the tree I just picked out, the first one actually has a name. Let's do this one first. We say the sine of the angle is the opposite of the hypotenuse. We call this one here the cosine. That's the adjacent over the hypotenuse. And lastly, this one here, we call it the tangent. That's the opposite over the adjacent. These are useful because they can help us find missing angles and missing sides on triangles, since your calculator has this function built into it. So let's have a look at an example here. Okay, can I? Not yet. Can I scroll down? Yeah? Okay. Right, let's have a look at an example here. I'll draw a triangle. We'll make it right angle. We'll say this side is 1, 2, and root 3. Now let's have one of the sides missing. Okay, 1 and 2. And I would like to find all the missing sides and all the missing angles. So the first thing I want to do is I want to find this side here. Okay, so we'll start off by using Pythagoras. So x squared plus 1 squared equals 2 squared. So that means x squared plus 1 equals 4, x squared equals 3, x equals root 3. So now my triangle looks like this. 1, 2, and root 3. Yeah. Okay. Now I would like to find this angle. I'll call it theta. So the nice thing is I actually have all the sides. So I can use sine, cos, or tan. So I'll just use cos as an example. So we can know that cos theta equals 1 over 2. So we need to know cos what angle equals 0.5. We have a way to find this on the calculator. If I can show you. If we want the calculator to tell us what is the missing angle, we have to press Shift Cos 0.5, and we get. Oh, let me put this in degrees. Yeah, with the -1. There we go. 60 degrees. So if I want to know what the missing angle is, the calculator can tell me by using something called Cos Inverse. And the calculator said it's 60 degrees. And we can test it. We can test it because if we calculate cos of 60, we should get a half. So let's test this. Cos of 60. We do get a half then. Okay, let's get the other side. Let's get this angle here. Well, the easiest way to get that is we know that theta plus 90, let's call this angle alpha, plus alpha, that should equal 180. And we know this, it's 60. This is 90, this is 180, so we can know alpha must be 30 then. So now I have everything on my triangle. 1, 2, root 3, 90, 60, 30. Well, I think a lot of this, maybe all of this, you've seen it already in middle school?
Yeah.
Yes? Okay, so just one last example to do, a little bit harder now. Can I scroll down? Yes? Okay. Let me give you this to try. And this one's a little bit hard because we'll say I want you to do this but without a calculator. Okay, so not using the calculator. Try this, but no calculator. And if it helps, I'll put brackets here. This part here is the angle. And I can help you even more actually. This part here is the triangle. You think you have it? What did you get? That's it, yeah. The triangle, we know because we're looking at sine, that the opposite is 5 and the hypotenuse is 13, and this is the angle and this is the triangle, and Pythagoras says this side here must be 12, and we're looking for the tan, which is the opposite over the adjacent. So we have 5 over 12 then. Okay, one more. Sine tan inverse x. Not as easy now. Okay. Anyone got an answer here? I think that sounds right. So the trick here was to recognize that this is the same as sine tan inverse x over 1. This is the triangle. This is x. This is 1. And Pythagoras says 1 plus x squared with a root. So sine is x over root. Yeah. Okay, so that was the hardest one today. Right, let's have a look here. Oh, sorry, do you have this? Yes? Okay. Try, we'll say, 1AB, 2AB, 3AB, 4AB, 5AB. Now these are all very short. It's only take maybe about 5 or 10 minutes. I don't even think it will take 10 minutes. Okay, so we can try these for 9 minutes. It's sleepy hot. Wait. Wait! Come back. What happened?
What happened?
Yeah. Make it good. Make it interesting. Make it an exciting story. Okay, yeah.
I was traveling on the street.
Oh, good. I like it, yeah.
And grandma was falling down.
Oh, grandma fell down.
Yeah,
Okay, yeah, good.
yeah.
That's not exciting. I wanted you like fighting people, or maybe you had to save her. She was being attacked.
Sorry.
Okay. No attendance for the first class, of course. I give it to you for the second class. We're just finishing. No, you can sit down. We're just finishing the first class. We're doing some questions now. Maybe you can try these because these are like what we did in physics, the trigonometry. No problems?
Just I don't have calculator.
Then you're not really finished, because what question needs the calculator? You need the calculator for question 4, no? Yeah. You should really buy a calculator. It will be helpful for you. Finished? About this or about something else? About the worksheet or something else? About this? Yeah, which part? Which one? 2B. Let's have a look. 2B. Okay, what's the question? Oh yeah. What do you need to know?
I don't know if it's radius
Or if it's degrees.
or
Good question, yeah. Let me tell you how you can know. Let me show you. In maths, come on. It's stuck. There you go. If I write a number like this, I must mean radians, because I only mean degrees if I do this. So if it's missing, then that means it has to be radians, and this has to be degrees. Sometimes students they see something like this and they think, oh, it's degrees. But I must have this if I want degrees. In fact, this is the normal mode, and this is the special mode, yeah, particular mode. So if I don't have anything, I always mean radians. I need to have something to tell me it's degrees. So in 2B, it must be radians then. Yeah. Okay guys, you can take a break for a few minutes there, and then we'll start the next lesson, okay? Who am I still missing, by the way? I'm still missing Sean. What, any other physics students? Am I only missing Sean?
No.
1, 2, 3, 5, yeah, 6, 7, 8, 9, 10, I'm missing some business students, aren't I? Who am I missing? Who? Oh! The three boys. Dhruv, Fahad, and Yash. Yeah.